Hello, in this video I'm going to be going over orbital notation and electron configurations and how to write those using our periodic table. So the first thing we're going to start with is writing the orbital notation. But before I get to that, I want to explain a little bit of what we're talking about in terms of electron configurations. So this link is in the notes right here. And essentially what we're writing using these configurations is what does that electron cloud around the nucleus look like? So again, our most current understanding of the atom is that electrons are found in this cloud, according to Schrodinger's model, around the nucleus, and there's a probability that electrons can be found somewhere in that cloud. And different elements have different shapes in terms of these clouds. That's represented by S, P, D, and F. That's the shapes. And then we also have different levels, 1, 2, 3, 4, so on and so forth, to also represent those different electron clouds. So I'm going to start with helium, which is really simple. Helium has an atomic number of 2, so that means if this is neutral, it's going to have 2 electrons. So you always start with 1s, and then we have to add electrons into this before we can go up to the other levels. So I'm going to have 1, use my keyboard for a second. So 1, 2. So this would be the electron configuration for helium. It has 1s, so it has only one energy level, and then that S shape is spherical. Okay, let's go ahead and do another one. So we're going to write the electron configuration for carbon in just a second, but let's go ahead and create it first. So carbon, we're going to start with 1s. So we have one energy level, and again, it's an S, it's the sphere shape. And carbon has an atomic number of 6, so that means we're going to have 6 electrons, assuming this is neutral. So here's the thing, we can only fit 2 electrons in that orbital and that level. So in order to get to those 6 electrons, I have to add another energy level. And so this one is 2s, and this one can also fit 2 electrons. So you're going to notice that all of the s orbitals can fit 2 electrons. And again, we're still only at 4 and we have to get to 6. So this is a p orbital. And with the p orbitals, they can be orientated in one of 3 directions. There's your typical x and y, and then z is like that 3-dimensional representation. So each of these p's can fit 2 electrons, and there's 3 in total. So you can fit technically 6 electrons in all of the p orbitals for like 2p, 2px, 2py, 2pz, all of those together. So 1, 2, 3, 4, 5, 6. This has 6 electrons. So this is what carbon would look like in terms of a physical model. So now let's go ahead and figure out how we're going to write that using our periodic table. So as you just saw with carbon, we did 1s, and then we filled it with 2 electrons. 2s, we filled it with 2 electrons. And then we had our 2 p's here, and we were able to fill that with 2 electrons. So if we look here, we know that carbon is atomic number 6, so that means that we're going to have 6 electrons in total. So you're going to notice that when you're filling this up, you have to go in level order. So when electrons are filling orbitals, they're going to be filling the lowest orbital first. So with our carbon, I'm starting here with 1s. I'm going to fill that first. And again, I have to get 6 electrons total filled in. So this is how we draw electrons, is with these single-sided arrows. And you're going to draw them like this. Electrons spin in opposite directions because they both have a negative charge. They don't want to really be that close to each other because like charges repel. And this is how we're going to be representing them. And again, in each of these orbitals, we can only have 2 electrons. So in the 1s, like you saw in here, we can only have 2 electrons. Well, now I have to go to the next energy level. So the next highest one would be 2s, which is what we did here. That was what we filled in next. And that can also fit 2 electrons. Now I'm at 4 electrons, but I have to get all the way to 6. So now if you look at the next one would not be 3s because that's not in level order. The next one in level order would be 2p. So it would go 2p, 3s, 3p, 4s, 4d, 4p, so on and so forth. So when you're filling this in, you want to go in level order. Now we are at the p. So like you saw, so there's 3 of them because of how they're orientated. So I only need 2. Now the thing is, you're not going to fill it in like this, okay? Because that's not what happened here. You need to have each electron needs to fill in an empty orbital first before they can start pairing up. Again, electrons, they don't want to be close to each other because they're like charges. So you always want to fill in empty ones first before you start pairing up. However, we only need for carbon 2 to be filled in. So now we have 6 electrons total. This would be the orbital notation for carbon. So now I'm going to show you how to write that using your periodic table. So I'm going to get all the way to carbon here. And how I like to look at this is I like to look at kind of like reading a book, one line at a time. So you're going to notice that helium is moved over here. And that's because helium is found in it has an s orbital. So you're going to notice, you can see all the letters. You have S, D, P, and F. So those are representing those different shapes. Obviously, we didn't see D or F in that example, which is okay. So when we're figuring out the electron configuration using our periodic table, I like to look at it reading a book left to right, one line at a time. And you're going to do that until you get all the way to the element you want, which in this case is carbon. So I'm starting here. So we have the numbers off to the side here. So that is indicating the energy level. So 1. And then we are in the S. So we have 1s. And then each box I like to count is basically representing an electron because that's how the electrons would be filling in. So this would be 1s2, okay? So we're actually going to write that on for our notation, 1s2. This is the electron configuration, which makes sense because 1s is where we started and 2 electrons are filling that in. So if I'm looking at my periodic table here, 1s and then 1, 2. However, I have to get all the way to carbon. So now I go to the next line. So 2s and then I count 1, 2. And I would write that down. 2s, 2. And that makes sense because that was the next level that we filled in, 2s, and then 2 electrons can fit in it. So you're going to notice with anything that has an s, it's going to have 2 electrons max. And then I'm going to continue reading. So I did 1s, 2, 2s, 2. And now I'm going to move over here. So now I'm in 2p. And again, we're only going to count until we get to the element that we want, which is carbon. So 1, 2. So 2p2. Which makes sense because 2p, and it's 2 because that's as far as we needed to go. But notice that a p could fit up to 6 electrons. Okay. So that's how you write an orbital notation and electron configuration using this diagram right here for orbital notation and using your periodic table for the electron configuration.